for Year 12 Physics, and this is Lesson 9 on forces, and this one is on circular motion. I'll also cover Lesson 10 because that's looking at problems on circular motion. So the type of motion of an object depends on where the unbalanced force acts. So if you've got a car that's moving in this direction and the unbalanced force is in the same direction, the result is the car is going to speed up. Now, next example is if you have a car that's moving in the direction of the red arrow, but the unbalanced force acts opposite motion, the car is going to slow down. In this example here, the car is going in this direction, but the unbalanced force is at 90 degrees to its motion, and the result is circular motion. So in Year 12, you've got to know about horizontal circular motion at constant speed. So these are the things here. So why is circular motion at constant speed accelerated motion? So for an object to move in a circle, there needs to be an unbalanced force. Why do you need the unbalanced force? It's to change the direction of motion. And this unbalanced force is called the centripetal force, and it acts at 90 degrees to the instantaneous velocity. That's also called tangential velocity. Now, the centripetal force has no component in the direction of motion, so it has no effect on the speed. So what I've drawn in this diagram is just different positions of an object going in circular motion. The blue arrow is at a tangent to the circle, and that's the instantaneous velocity. And you can see for circular motion, the direction of the velocity or the speed is changing the whole time. And what is responsible for the change in the direction of speed is the centripetal force, which are my green arrows. Okay, whenever there is an unbalanced force, that will always result in acceleration, and the direction of acceleration is always the same as that of the unbalanced force. So if you look at these arrows, the centripetal force arrow and the acceleration arrow kind of overlap, but I've just drawn them slightly apart so that you can make out one is centripetal acceleration and the other one is centripetal force. So that's what I've said over here. Okay, now what is it that provides centripetal force? If it's a ball on a string, you've got tension force. If it's a car on a circular road, it's friction between the tires and the road. So it's not enough to say just friction, you've got to say where the friction acts between. If it's planets going around the sun, it's a gravity force that holds them in orbit. Now what happens if the centripetal force is removed? Like if the string breaks or if there's oil on the road, then there's no longer any centripetal force. So it'll stop accelerating, it cannot change direction anymore. So the object will go in a straight line at constant speed at a tangent to the circle. Okay? And there are a couple of formulae used in circular motion. So the formula for centripetal acceleration is v squared over r, because unbalanced force, F is equal to ma. You substitute for a using v squared over r and you get Fc is mv squared over r. In case the speed is not given, but you know how long something takes to go around a circle once, that's a period, then you just use distance over time, because the circumference of a circle is 2 pi r and the period is your t. Okay.